Right, we are back. This is Techmath2. We're looking at chapter 10, 10.1. So that is on page 433. We're working with imaginary numbers. So we've done this already. I likely used the lowercase I. I forgot engineers use a lowercase j for imaginary numbers. So j squared is equal to -1. That, right, seems impossible, but that's why it's called an imaginary number, okay? And if you accidentally use the little lowercase I won't take off for it. It means the same thing. Okay, so 4j squared. So when you have the square root or an even root of a negative thing, you replace the -1 with j squared. So -4 is really 4 times j squared, which is, remember, -1. And now we can evaluate it. That's 2j. Same thing here. That's 64j squared, 8j. Again, if you put this down, 8i, like for the imaginary number, that's fine. Those are interchangeable. This is what mathematicians use. This is what engineers use. So, okay. The second part that I wanted you to see in 10.1 is like when you add and subtract them or multiply them or divide them, you treat it just like a variable. The only thing is it's a special variable that if you ever get to a squared, you have to replace it with a -1. All right, so it's really never more than just a first degree. So 3j minus 8j, that's -5j. 1j plus 4j is 5j. -4 times 9j is -36j. And 32j over 8j, the j's canceled just like they would if it was a variable. And 32 divided by 8 is 4. Okay? So that is it for 10.1. 10.2, we're graphing on a coordinate plane where x is the real number system and y is the imaginary number system. And so I was really bummed about this. I thought when I learned about it, my instructor had kind of prefaced it right before the weekend and said, "Oh, we don't have time. We'll cover it next week." And my mind went wild. It's going to be all this crazy imaginary numbers stuff, and it'll be some weird three-dimensional thing that you have to invert this or do that. Yeah, no, it's just an XY chart. And so when you look at point 1 here, that's 0. The point there is 0, 4. And what you do, instead of writing 0, 4, 0 is the real number. That's the x, is the real number system. And the y is the imaginary number. So you just write 0 plus 4i or 4j. That's it. So this is just a coordinate x and y. And that's what the graph looks like. It's from the origin straight up, okay? Again, if they're being strict, they say the number plus the, a lot of times, if you're not graphing it, you just say like over here, -5j, 5j, -36j, 4, but if you are graphing it, you usually put the 0 there or the 0j on like the next one. 2, this is at 8 on the x-axis, so that's 8 plus 0j. The reason that you write plus 0j is because that should be like a coordinate like 8, 0, where 8 is the real number and 0 is the imaginary number. So we don't write it like this, we write it like this, 8 plus 0j. Okay? 3, that's down here. So that's 0 right or left. So 0 plus -10j, or you could just say -10j, that would be fine. And -6 plus 0j would be that one. Okay. So that's what 14 looks like. Pretty basic stuff. xy, and you just put whatever's on the y, you throw a j on it. So let's look at 10, 3. So conceptually, this is a little tough to get your head around, but in actually working it, like what you have to do is pretty basic stuff that should be like review for you. So take a look at 10.3, like number 22. And in subtract, so look, they have -1 minus 5j plus 7, and they have 8j plus 1 minus j. And so just like what you did before in algebra is combine like terms. That's all you're doing. So -1 goes with the 7, so we'll make that 6. And then there's nothing for that, so it just stays minus 5j. And that's it. The 8j gets to go with the -1j, so that becomes 7j. Usually you put the j second and the real number first, so 1 plus 7j instead of 7j plus 1. That's just considered good form. I wouldn't mark it wrong. If on a test you wrote 7j plus 1 instead of 1 plus 7j, I would still give you full credit. Okay. The reason that you want to write it like first and then second is just so you get used to this is the x and this is the y, but if you're graphing it. All right, let's take a look at 23. If this is a vector that's got an imaginary in it, 1.8j, that's vector 1. And then vector 2, we're looking at number 23 here, is 2.3 minus 4.9j. And you want to combine those vectors and find the resultant vector. You're just adding. You're just adding them together. So 6.5 plus 2.3 is 8.8. And positive 1.8 and negative 4.9 is negative 3.1. And that's got a j on it. So we just added the numbers with the numbers and the variables with the variables, and you're done. Okay. Next one is 375. You got to write down the correct problem there. 375 minus 15j is the first vector. And if you combine that with -150 plus 40j, the resultant vector will be 225 plus 25j. So you're just combining the 375 and -150, that's 225. -15, positive 40, that's positive 25j. All right, let's take a look at 27. What if they give you the resultant? Okay, and then they give you a vector, 1, and then they tell you to find vector number 2. So check it out. If they give me the first one as 7 minus 3j, that's the resultant vector. And then 1 minus 5j is vector 1. Well, if I just subtract the resultant minus vector 1, that should give me vector 2, because if I add this to this, it should equal that. And so you could just about do that in your head, right? Because you could say, okay, blank plus 1 gives me 7. Well, that's going to be 6. Or you could just say 7 minus 1 is 6. -3j minus -5. Minus a negative is a plus. So -3j plus 5j is 2j. And you can always work backwards. You could say 6 plus 1 is 7. 2 plus -5 is -3. So you should always be able to check your answer back. So they gave us a resultant of 6.4 minus 3.9j and -1.4 plus 2.8j. And if I just subtract those, So 6.4 minus negative 1.4, so that's plus. So that's 7.8. And negative 3.9 minus 2.8, so they're both negative. So you combine them and keep it negative, negative 6.7J. All right. On the next one, we got 340 minus 25J. And we've got negative 180 minus J. So 340 minus negative 180 is then, that's a plus. So you actually add them together. You have 520. 520. And then negative 25 minus negative 1J. So that's plus 1. So negative 25 plus 1 is negative 24J. Okay. And then the last one, 1.79. J, oh, they don't have a number in front. And then 2.58 plus 2.44J. Okay, so you got 0 minus 2.58, so that's negative 2.58. And you got 1.79J minus 2.44J, that is negative 0.65J. Okay. So hopefully pretty easy stuff, right? Very much review, combining like terms. Let's look at multiplication. And so this, we're going to be multiplying a binomial times a binomial, but there's one extra special rule. J squared will always be replaced with a negative 1. So you are going to take a binomial times a binomial, but you're not going to end up with a trinomial, because the squared term is going to turn into a negative 1. So check it out, 10.4 is 7. We're looking at number 32. 7 minus J times 5 minus J. So you do the distributive property twice. That is 35 minus 7J and negative 5J plus J squared. And so we can combine like terms, but also J squared is negative 1. So we get 35 minus 12J, because those are both negative numbers, so we combine them, keep it negative, and then minus 1. And now I can put that negative 1 with the 35. So 34 minus 12J is the answer there. All right. Easy peasy lemon squeezy. Again, very much review. Let's look at division. 10.5. What if we have, like number 44, we got 5 plus 2J, or 3J over 2J. So what is going on there? Well, let me show you. We basically split it to 5 over 2J plus 3J over 2J. This, the J's cancel. So we just get 1.5 there. This, we cannot ever leave an imaginary in the bottom. So remember how we get rid of an imaginary. We did this in 115. We worked imaginaries a little bit. You multiply top and bottom by J. So what happens? Well, I end up with 5J over 2J squared plus 3 halves. So what is J squared though? That's negative 1, right? So we end up with 5J over negative 1 times 2 is negative 2 plus 3 halves. And then if we make it into decimals and put the real number first, so 1.5 first and negative 2.5J second. Okay. If they would have wanted it as fractions, we would have left it as fractions. But that is a little tricky because, you know, the j's cancel, you get the 1.5, but this, you can't leave a j, an imaginary in the denominator. So there is a second part. Let's look at 44b and see what that one looks like. That is negative 12 plus 17j over negative 10j. So look at what happens. We end up with negative 12 over negative 10j plus 17j over negative 10j. Here the j's just cancel, and that's negative 1.7. So that's super easy to do. This is not super easy to do. 12 tenths, that's going to be 1.2 eventually. But we got a j, but it's in the denominator. So you can't just automatically just pop it up to the numerator. That's a big mistake. You got to multiply top and bottom by the j. Same on top and bottom. Now I get j squared on the bottom. So I got 12j on the top now. I got 10j squared on the bottom. And then that's actually negative 10. So I got 12 over negative 10. J minus 1.7, that should go first, the negative 1.7 first. I can divide that and get negative 1.2, and it's got the J on there. So the real number first, the imaginary number second, both of them negative. Okie dokie. So that's a little tough. Now, I've had students in the past, when I've taught this course, say, look, if I know there's a j on the bottom, can I just make it negative and put it on the top? And yeah, you could like skip showing me this work if you just went from this and made it negative to that. You know what I mean? That would be fine. Or you can show the work. It's fine. You could probably, what would be a good idea on the homework, show the work until you get the hang of it. But like on the test, if you skipped the step of multiplying top and bottom by j, I would be okay with that still. All right, I wouldn't take off. I'd still want to see some work. I'd still want to see the divide. But if you went from this step right down to that step, that would be fine. All right. Let's do another one. Like 46. That's a tough one. And again, we did this in 115, but not a lot. Where we take 10 minus 5j divided by 1 plus 2j. And so for that, because there's a number and a variable on the bottom, we multiply by its conjugate. The conjugate isn't the opposite, it's just one thing is opposite, so it's 1 minus 2j. Minus 2j. A lot of people go, oh, so opposite. No. The opposite of this is negative 1 minus 2j. I only changed one of the signs. So that makes it a conjugate, not an opposite. All right? And so now we multiply top and bottom by the same thing, by the conjugate. And now we distributive property twice. So 10 minus 20j minus 5j plus 10j squared, but we're going to make that negative 1 in a second. 1 minus 2j plus 2j, and then minus 4j squared. And if you take a look at that, those cancel off. That's what conjugates do. The middle term cancels away. And so we have 1 minus 4j squared. But remember, j squared is really a negative 1. That's really a negative 1. So this is negative 10 and positive 10, which is 0. I'll write it down for you. Negative 10, or plus 10 minus 25j over 1. A negative times a negative is a positive 4. So look at what happens. The 10s cancel on the top. And we got negative 25j over 5, and then we can divide and reduce. So negative 5j. Again, if we were graphing it, if they then told you graph, you wouldn't just write negative 5j, you would write 0 minus 5j. Because then you know x is 0 and y is negative 5. Okay? But If they don't, you know, that is strict complex number form, but I would accept this too if you just had negative 5j instead of 0 minus 5j. All right. Okie dokie then. Let's keep rolling along. Hopefully you remember that from 115. And then let's see, I want to do one more. And then I was going to show you a calculator operation, right? 10-6. Yep. Okay. So here, one more, but it's got 3 problems. So 52, this is 0 plus 48j over 0 minus 6j. Only don't worry about the zeros. Just drop those off. So that's 48j over negative 6j, and the j's cancel, and then you just get negative 8, and that's it. So it's negative 8 or negative 8 plus 0j if you're graphing it. Either one. Okay. Next one, we have negative 9 plus 0j over 0 plus 3j. Again, that and that are away, so it's negative 9 over 3j. So this is a little trickier. You can divide it and get negative 3 over j, but we cannot leave a j in the denominator. So we multiply the bottom by j and the top by j. So you get negative 3j over j squared. That is negative 3j over negative 1. That is just 3j. Or again, you could write 0 plus 3j. Either or. Okay. And then let's do C and D, 52. And then I will show you how you can use your calculator to help along with these if you want to. So that was A, that was B. Here comes C is 0 minus 14j over 0 minus 5j. So the j's just cancel. You just get, the zeros aren't there, the j's cancel, you get 14/5. And when you divide that, it becomes what, 2.8? Or 2.8 plus 0j. And then D is negative 7 plus 0j over 0 minus 4j. So again, this is very much like this one. So that's not there. So you get negative 7 over negative 4j. The negative over a negative is a positive, and you can actually divide it to 1.75. So you get 1.75 over j, but you cannot leave that j on the bottom. Again, I've had students in the past go, look, I'm just going to make it negative 1.75j, and we're good. Like when I move it up to the top, that makes it negative. Yeah, I mean, I'd like you to understand you multiplied top and bottom by j. That's where the j came from on the top, and on the bottom, that becomes negative 1. So you've got 1.75j over negative 1, and that's why it becomes that. But if you want to skip that work and just go right from there to there, I'm okay with that. All right? And then the last one that I want to show you is we can, you can key these into your calculator. On your calculator, the TI-83 and 84, they don't use J, they use I. So I'll show you where to find that. We'll just do one problem here. And I don't know, maybe for the division ones, it might be worth it to check it with the calculator. But I think for the addition ones, it's just easier just to do by hand, I think. So take a look at 54 on 10.6, and I'll show you how to do it on your calculator. So negative 10 plus 7j plus 37 minus 12j. So I would likely do this one just, you can almost do it in your head. I would say the little calculator trick might come in handy for like a division one where you're going to multiply by the conjugate or something to check it. But we're just going to look at 54 here. I'll show you on the calc what that looks like. So where is the imaginary? There it is. Okay, so look, we can type this in just as it is on the board. Parenthesis, -10 plus 7. And now I want an I there. And if you take a look at right there, there's an I, but I have to do the yellow. So second, and then the decimal. And then that pops the I. For our calculator, that is the imaginary instead of J. Like I said, math people do I, physics people do J. 37 minus 12I. Okay, so I typed exactly what you had there, and now we hit enter, and there it is, 27 minus 5. Okay. And same for the second one. It's almost more work to get it typed in than it is just to do it individually. So negative 0.57 plus 2.74 J. Oh, see, I put an I down instead of a J. If you do that on a test, I'll still give you full credit. That's fine. Imaginaries can be written either way. All right, that is it. 10-1 to 10-6. Have a good night.